Welcome! Today we'll go over some of the most important concepts in physics. We'll start with displacement, acceleration, and velocity. As this car barrels down the freeway, it demonstrates velocity by moving in a general direction. It shows acceleration by changing its velocity, and it demonstrates displacement by changing its position. When these objects are dropped, they will fall at the same velocity, despite their significant difference of mass. How fast the objects will fall is based on the acceleration of gravity, which is negative 9.8 meters per second squared on Earth. These objects are displaying the visible light spectrum by going from red, with the lowest wavelength, to violet, with the highest wavelength. Newton's first law is that objects resist changes in motion. As you can see, the box resisted moving and ended up at the back of the bus, and when the bus stopped moving, the box tried to continue moving, thus demonstrating inertia. Newton's second law, force equals mass times acceleration, is demonstrated by a train pummeling a sports car at high velocity. The train's force is much higher than that of the sports car due to its higher mass and similar acceleration. The collision of this epileptic bus on these barrels displays Newton's third law. For every action there's an equal and opposite reaction, by showing the bus pushing on the barrels and the barrels pushing on the bus, slowing the bus down and sending the barrels flying. As this vehicle is propelled from this high-rise, it demonstrates projectile motion by having a constant horizontal velocity while accelerating downwards by the force of gravity. As this tomb raider tries to desecrate this crypt, the elastic material attached to the tomb and the car returns to its initial size and shape. When a vehicle with lower mass collides with a train, it moves the train less than a vehicle with a higher mass and a similar velocity, due to its lower momentum. As a train rockets forth through a tunnel, it demonstrates the Doppler effect, a change in frequency as an object's position nears a viewer. As this plane flies in circles, it demonstrates circular motion. And as it is released from its captivity, it continues going in a straight line for a short time. As these balls travel from the top of the hill to the bottom of the hill, they show the conversion of potential energy to kinetic energy. As this plebeian flips these switches in rapid succession, he displays circuit electricity, as seen by the changes in light levels due to lights turning off and on. Ice cubes in water show thermal physics. They do this by gaining heat from the warmer water, causing them to melt. Normally, if you were in his position, you would notice a static charge being built up by transferring electrons. However, in humid conditions such as these, static tends to not build up.